Good afternoon. This is At Home Learning, May 4th through May 8th, Session 3. It is on multiplying monomials and power of polynomials. Remember at the beginning of the year we talked a lot about squaring a number. Squaring a number means taking what is in the parentheses and multiplying it by itself twice. We do it twice because the exponent is 2. For example, when we had 4 squared, it meant it was 4 times 4, which was 16. So I'm going to go over some of the common exponents, and I'm going to go over of what they exactly mean. So 2 to the third means 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 3 to the fourth expanded out is 3 times 3 times 3 times 3. If I look at that, 3 times 3 is 9, 3 times 3 is 9, that is 81. This is what we mean by exponents. 4 to the third expanded out would be 4 times 4 times 4, and 4 to the third is 64. 3 to the third would be expanded out to 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. We are going to take the concept of expanding exponents out with variables. So now we're going to multiply monomials and powers by other exponents. Use what you know about squaring a number and apply. So what you're going to do is you are going to expand out. In this problem, the negative stays there. Then this is 3a, because of the squared number right there, the 2 above the a, it says right the a twice. And then you have b, b, b. And then you have a 5 and an a, and 1, 2, 3, 4 b's. When you look at this, you are going to take care of the sign. You are going to take care of the number, and you are going to take care of the letters. If you do that each time, you will be more successful. In all of this line, there is only one negative, which it means it's a negative times a positive, so that whole thing is going to stay negative. Then I'm going to multiply 3 times 5, just like normal multiplication, and I'm going to put 15. I'm going to physically count the a's that are present. There's 1, there's 2, there's 3. Therefore, it is a to the third. Then I'm going to physically count the b's. 1, 2, 3, 4, 5, 6, 7. And then I will write b to the 7th, and that will be your final answer. Going to go through a couple more examples. So this one expanded out will be 2ab, ab, negative 3aa, b, 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 b. 1, 2, 3, 4, 5. Okay, so this negative looks funny because it's in the middle. It will look like that it is a minus. It is not. It is still a negative. So, again, we do signs, numbers, letters. So, I have one negative, so it's going to stay negative. 2 times 3 is 6. A, I have 1, I have 2, I have 3, I have 4, a to the fourth. I have b's, I have 1, I have 2, 3, 4, 5, 6, 7, b to the 7th. And so that would be your final answer. Now, what you're going to run into is you are going to run into 2 different types of problems, and they are hugely different. So exponent in the parentheses versus exponent outside the parentheses. There's a huge difference. So see 3a to the third, 3a in parentheses to the third. In this first example, this 3 is attached only to the a. So that is 3a, that's expanded out. This one is a rubber stamp of 3a, 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 which 3 times 3 times 3 is 3 times 3 is 9 times 3 is 27. An a, an a, and an a is a to the third. They are vastly calculated different. Parentheses you will have to watch out for. When you have parentheses, what you're doing is you're taking the exponent and you're pretending it's a rubber stamp. So you're going to expand it out. 3x, 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 3x. I wrote it 4 times because of the exponent of 4. Multiply. Then I'm going to do my signs, my numbers, and my letters. Now, on my signs, they're all positive, so it's going to stay a positive. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. X, and there are 4 of them. And that would be your final answer. They get a little bit more expanding out and complicated. That is fine. This is going to be 3n. I wrote it twice because of that exponent right there. 4n, 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 4n. I wrote it 4 times because of that. Multiply the numbers and then count up the letters. 3 times 3 is 9. 4 times 4 is 16. 4 times 4 is 16. So you have 16 times 16 times 9, which is 2304. Then we're counting up the physical ends. I have 1, 2, 3, 4, 5, 6, n to the 6th, and that is your final answer. When you have to evaluate an expression, what you will do is you will take that 2 and you will put it right there, and you will take that 3 and you put it right there. So, let me erase that, and so I have more room to write. Should have done that on the top. Oops. Medium eraser. It's not erasing. Let's see what I can do. Oh, there we go. Sorry. Okay, here we go, erasing. So I'm going to rewrite this as -4 times 2 times 3, all of that to the third. So it is -4 times 2 times 3 times -4 times 2 times 3 times -4 times 2 times 3. It's going to be a quite large number. So, again, I'm going to do signs, numbers, and I don't have any letters. Okay, here's how the sign works. If there is an odd number of negatives, then it is going to be a negative. So a negative times a negative is a positive, times another negative is a negative. So it goes negative times a negative is a positive times a negative is a negative. So this whole thing is negative. Then I have 4 times 4 times 4, which is 64. And then I have 2 times 2, which is 4 times 2, which is 8. And then I have 3 times 3, which is 9 times 3, which is 27. And so that is 64 times 8 times 27. And therefore your final answer is $13,824. And this is what exponents do, is they grow quite rapidly. The higher the exponent, the higher the number. If you have any questions, please get a hold of me, and we will go over how to multiply monomials and polynomials. The biggest thing is, especially when you have problems such as this, that you go ahead and expand it out, find the power of an, it's like using a big stamp. So stamp it out and then count them up. Multiply your numbers and then just physically count your letters. Hope this helps on session 3. Thank you.